Hello, Matthews Gatos here. In this video, we're going to be looking at probability involving permutations and combinations. So let's begin by reviewing permutations and combinations we've done so far. So the first thing we did, we looked at factorials, which is starting at any whole number and reducing by 1 each time until you get 1, and 1 means stop. This is really just a shortcut anytime you were arranging all n objects. So if I'm arranging all 5 objects, 5 factorial ways of me doing that. Permutations are when I'm not arranging all the objects. Or you could use it when you are, but the shortcut here would be NPR would be when you have n objects and you're arranging r at a time. If you're arranging all of them, just stick with the factorial. This is when order is important. So when I'm arranging things where the order matters. If I have objects or items that I am arranging, always be on the lookout for repeated objects or repeated letters or repeated digits, because anytime you have that when you're doing an arrangement, you always need to divide by the ways of arranging the repeats. Now, if order doesn't matter, then we're dealing with a combination. So a combination is just a permutation divided by the ways of arranging the objects, r factorial, because order does not matter. Okay, let's try an example. We have 2 cards that are selected without replacement. As soon as I hear without replacement, I know they are dependent events. So the second card depends on what the first card was. We want to determine the probability that both the cards are kings. So we're going to do this with the multiplication law and with combinations. So there are 4 kings in the deck. I'm doing this without replacement, so let's look what that would look like. So I want the probability of getting a king and a king is the probability that my first card is a king and that my second card is a king, given that my first card was a king. So for the first king, I have 4 out of 52 cards that are kings. Now I keep that card, there's only 51 left, and because I got a king on the first pick, I only have 3 chances of getting a king on the second pick. So multiply those together, and in lowest terms, I get 1 over 221 as my probability. Now let's look at that as combinations. So this could be a combination question, and cards for the most part are combination questions because it doesn't matter the order that I pick which king, as long as I get that king. So for this one here, I can look at it all together. So I want 2 kings. There are 4 of them and I want 2 of them. Out of 52 cards in the deck that I want 2. So I can enter this into my calculator as well, and I should get the same answer. I did get the same answer, so I'm happy about that, because it doesn't matter which method I use, I should get the same answer. Okay, let's look at this one here. Now we're going to look at 5 card hands. I want to know the chance that I'm going to have 4 aces. We're going to leave our answer in combination notation. Now, first thing that you need to remember is that I have 5 cards. So if 4 of them are aces, 1 of them is not an ace. So 1 of them is not an ace. We always have to add up to 5 cards. So I want 4 aces, and there are 48 not aces. So for my aces, there are 4 of them, and I want all 4 of them. And then I have that missing card. I still need that last card to make up 5 cards in my hand. So there are 48 not aces, and I want 1 out of a total of 52 cards in the deck, and I want 5. Okay, this one here I have 4 tens and 1 ace, so that is 5 cards, so I'm good to go. So 4 tens and 1 ace. Okay, so here we go with this one here. I want 1 ace. There are 4 aces, I want 1. There are 4 tens, I want all 4 of them. Out of 52 cards in the deck, of which I want 5. Okay, this one here has to be a jack, queen, king, and ace. So again, that's 5 cards. It doesn't have to be in the same suit. That's just the picture I found. Could be in any suit, as long as I'm having a king, queen, jack, 10, and an ace. So looking at that, it doesn't matter the suit, okay? So for this one here, I can have 1 of any color. So for the ace, for example, there are 4 aces, I want 1. There are 4 tens, I want 1. 4 jacks, I want 1. 4 queens, I want 1. 4 kings, I want 1. Out of 52 cards in the deck, and I want 5. So I can do this all together, or if you notice, these are all 4C1s, and it happens 5 times. So instead of punching that all into my calculator, I can say 4C1 to the exponent of 5 divided by 52C5. So just to show you it doesn't matter which way you do that, you can see I entered both ways into my calculator and I did get the answer. The probability is quite small, but they are equal. So 2 different ways you could look at that question. Okay, for this one here, I have 5 cards. I want at least 1 jack in my hand. Okay, so if you look at this, I can have 1 jack, 2 jacks, 3 jacks, or 4 jacks. The only case I'm not considering when I have a minimum, meaning at least, is 0 jacks. So 0, 1, 2, 3, 4, those are all the cases that are possible. So I could do all of these cases here, add them up together, or I could just look at all the cases minus the no jacks. That will give me at least 1. So that's what I think is the easiest way, so I'm going to do it that way. So you can see here's the jacks, but I don't want any of them. Okay, so to pick at least 1 jack, all cases means 100%, as a decimal is 1. Take away, there are 52 cards in the deck, take away 4. There are 48 not jacks, and I want 5 of them out of 52 cards in the deck, and I want 5. So that would be your answer. Subtract those and you would get the answer for the at least 1 jack. Okay, in this one we're having tiles. So we have the words counted, 7 letters, no repeats, spelled out on Scrabble tiles. 2 tiles are chosen randomly, 1 at a time, and placed in the order they were chosen. So since they're placed in the order they are chosen, order is important, making this a permutation. So I want to know the probability that the tiles are CO. CO in that order, only one way that can happen. So CO, 7 letters, and I want 2 of them. So 1 out of 7P2, it's a 1 in 42 chance of that happening. Now, you might like to do it in multiplication instead of that notation. So I can say, picking my C and my O, there's 1 C out of 7 letters. There's 1 O out of 6 letters. 1 out of 7 times 1 out of 6, that is 1 out of 42. So 2 different ways you could do that question. Okay, this one says that they are both vowels. Both vowels. So I want 2 vowels. Let's look at my word. I have 1, 2, 3 vowels. So there are 3 vowels and I want 2 of them out of 7 letters, and I want 2. Okay, plugging that into my calculator, I get 1 out of 7. Again, if you want to do it the multiplication way, there are 3 vowels out of 7 multiplied by 2 vowels out of 6. So multiplying those together, you will also get 1 out of 7. So 2 different ways that you could do that question. Okay, Mike's MP3 player contains 50 songs. If he listens to 10 songs on random, determine the probability that the playlist contains Mike's 2 favorite songs. Okay, so on his 50 songs, he has 2 favorites and 48 other songs that he really likes. They're just not his favorite. So we want to determine the chance of this happening. Again, order is not important because it's just a playlist. It doesn't specify where in the playlist his favorite song has to be. So I want 2 of his favorite songs. I have 2 favorite songs and I want 2 of them. Okay, I have 48 songs left, and to make up to my 10 song playlist, I'm going to need 8 more. So 2 plus 8 adds up to my 10. Out of 50 songs in total, and I am selecting 10. So I can put that into my calculator. I get a fraction. I want it as a percent, so I times by 100. So the probability to the nearest hundredth will be 3.67%. So an almost 4% chance of that happening. Now let's compare that question to this one. Okay, so same scenario, but he wants to know the probability that one of his 2 favorite songs is at the beginning and the other is at the end. So it's not just that they're on the playlist anymore, they're specifying a specific position. So in this case, order is important. Okay, so he's got a favorite song at the beginning and a favorite song at the end. So of his two favorite songs, I want one there. I'm left with one favorite song and I want one there. Okay, I am left with, of the 48 songs, I want to choose 8 of them to make up my playlist. 8, 1, let me try that again. 1, 8, and 1, that adds up to 10. Out of my 50 songs in total, and I am arranging or selecting 10. So I can put it into my calculator exactly like that. I want it as a percentage. So you can see here's the percentage to the nearest hundredth, 0.08% chance. So not very likely because I made a specification of order. Okay, this one here, City Council consists of 9 men, 6 women. We want 3 representatives to be chosen to form an environmental subcommittee. What's the probability that the mayor, Jim, and 2 women are chosen? So mayor, Jim, and 2 women are chosen. Okay, so I want the mayor. There's one mayor, and I want him. Okay, now because I'm choosing the women, the mayor doesn't really affect the women. Okay, because he's in the man category. So women, 6 of them, and I want 2 out of a total of 15 people, and I am selecting 3. Okay, so putting that into our calculator, you can see that we get 3 out of 91. So that would be your chance that mayor and 2 women are on the committee. The next one says, what's the probability that 2 women are chosen if Mayor Jim must be on the committee? So if he has to be on the committee, let's just take the mayor out of the selection process entirely. So I'm going to take him out. So instead of having 9 males, I really only have 8 because I've taken out the mayor. Instead of having 15 people, I really only have 14. And I'm not choosing 3 members anymore. I'm only choosing 2. Okay, so just take the mayor completely out of it. Now, in this case here, order is not important because I'm just looking that they're on the committee. So I want those 6 women on the committee, sorry, the 2 women out of the 6. 6C2 out of 14C2. So since the mayor's on there, it's really only a committee of 2 that I'm looking at. So I divide those together and I get 15 out of 91 ways. Okay, my last question here. A hacker is attempting to break into a friend's security protected file. What a nice friend. The friend foolishly tells the hacker the numbers that are in the 4-digit PIN, but not the order and how many times each digit must be repeated. Okay, so we want to determine the probability the hacker is going to guess the 4-digit PIN on the first attempt if the friend tells her that the PIN contains a 4, 5, 6, and 7. Okay, well, since it's a 4-digit PIN and I'm using 4 digits, that means there are no repeats. Okay, so the number of ways of arranging 4 digits with no repeats is 4 factorial. And 4 factorial, 4 times 3 times 2 times 1 equals 24. So the chance that the hacker correctly guesses on the first try, 1 out of 24. Okay, now let's say the friend says, okay, my PIN uses the digits 4, 5, and 6. So since there are only 3 digits for a 4-digit PIN, that must mean that there is 1 digit that repeats. But we don't know which one, so this means cases. Okay, so one example is the 4 repeats, another the 5, another the 6. So I've given an example of each one, just so you can kind of see what that is. So really, I still have 4 digits that I'm arranging. However, I have 2 that are identical. So I need to divide by the 2 factorial ways of arranging the identical digits. Okay, so I want to figure out how many possibilities this is altogether. So altogether, that's 36 different 3-digit pins, or sorry, 4-digit pins with 3 digits. So the chance of the hacker guessing, 1 out of 36. Okay, and this one here, we tell the hacker, my 4-digit PIN only uses the digits 4 and 5. So since there's only 2 digits for a 4-digit PIN, 2 of the digits can repeat or 1 of the digits could repeat. Let me show you some examples. Okay, so here's an example. Let's say the 4 repeats. So if the 4 repeats, well, I have to have it with the 5, so that would be 3 repetitions. Or the 5 repeats, so 3 5s and a 4, or both of them repeat. So in each scenario, I still have 4 digits I'm arranging, so 4 factorial. In this case here, where the 4 is repeating, I have 3 of them, so 3 factorial. In this case, I have the 3 5s, so divide by the 3 factorial ways of arranging the 5s. In this case, the 4 repeats 2 times, and the 5 repeats 2 times. Okay, so those are just examples to help you illustrate what it is. So these are all cases, so I would add these up together to figure out the total number of possibilities. So the total number of possibilities is 14, so the chance of the hacker guessing, 1 in 14. So it looks like so far the one where I have 3 digits is the best option. Now, let's say your friend is not too bright and says, I have a 4-digit PIN and I only use the number 4. So if I have only 1 digit for a 4-digit PIN, that must mean that my PIN is 4, and then 4, and then 4, and then wait for it, 4. Well, 4444 is the only PIN. So unless it's a really bad hacker, I would say they have a 100% chance of guessing your PIN. Okay, to summarize this lesson, if order matters, use permutations. Pay attention to your restrictions and always divide by the ways of arranging the repeated items. If order doesn't matter, you're going to need combinations. Make sure you always add to the total, like having 5 cards or 4 songs. Watch for restrictions that might reduce the total, like that Mayor Jim question, and look for shortcuts for at least and at most questions, just like that Jack question that we did. Okay, so I am 101% sure I know more about probability than you. What do you think about that statement? Okay, you guys can go on and do your practice questions. Answers are on D2L. I hope this video helped, and I look forward to seeing you for the next one.